In the precursory adventure of this series on YouTube on the internet, I built an entire miniature factory out of super alloys just so I could process Minecraft ores. Meanwhile, on the other side of headquarters, I used the newly processed Naquata to do several industrial upgrades in a 0.5 square mile radius, and all of this was just to prepare myself for the next step of gaming, the fusion reactor, which comes with even more new nonsensical but useful materials, as well as excessive amounts of free power. But major roadblocks still stand in my way. There was still more technology to obtain before the unlocking of fusion, and to start off today, it was time to begin an extremely expensive project, for a small efficiency boost. As of the current times, most of the things you see right here are made from assembling machines. Most assembling processes only needed items, but sometimes they needed molten material injection. To recap, how I dealt with this was that each auto-crafting pattern for assembling had everything in solid form, and for each assembling auto-crafting task, all of the solid items would be sent to this chest. The materials to be melted would be sorted into this extractor, and everything else, along with the extracted stuff, would be dumped into the assembler. However, after about 100 hours of playing, I noticed a pattern. The only three molten materials that were commonly used were molten polytrifluoroethylene, polyethylene, or styrene butadiene rubber. So I had an idea. I would replace the assembling machine with the Grejicality multiblock version, the large assembling factory, and rather than melting stuff on demand like what I am doing right now, I would automatically import the three most commonly melted solids into three fluid extractors, each feeding into a quadruple fluid hatch in this factory, so that I would have several Olympic swimming pools of polymers waiting on standby to be used. This was cool and all, but the costs were costly. The large assembling factory needed tempered glass and the infamous assembler casings made from Sterile 100 super alloys and tungsten frames. However, due to the massive technological leaps that I had accomplished in the previous episode, this would be easy. The Sterile 100 was obtained by depositing iron, chrome, tungsten, and molybdenum in the alloy blast smelter, and tungsten could be smelted rapidly by my new Naquata blast furnace complex. Surprisingly, the first steps did not lead to me discovering that I would actually need 500 steps, and the only thing left were some other casings, fluid hatches, energy hatches, overly complicated large assembly factory controllers. Plus I made 3 insane voltage tier extractors as part of the plan. All of this would be built on the insane voltage power grid in the general machine quadrant of the space station, and the matter energy system would be used to automatically export sheets of the 3 aforementioned polymers into the extractors. All of the resulting molten material is then pumped with fluid conduits into the quadruple fluid input hatch, where all of the fluids shall remain undisturbed until I ran an assembling process that needed something molten. And along with this major assembling update, I would have to redo all of the assembling auto-crafting recipes, since manually melting stuff was now extinct. All of the recipes for assembling cables were now approximately 33% simpler, and making surface-mounted devices was now slightly more real. But besides these rather small changes, the main improvement caused by this factory was that upgrading its speed would be much easier. Previously, when I wanted a normal machine to go faster, I would have to scrap it and make a higher tier version of it from scratch, which was also expensive. But if I wanted this multi-block machine to go faster, all I had to do was upgrade the energy input hatches, and perhaps add a parallelization hatch, for instant performance improvements. So now that I had become a assembling pro god hacker, it was time to leap towards my next extremely expensive project. For an actually rather large efficiency boost, solar panels. The current method of powering this entire space station factory was to burn hundreds of thousands of diamonds in these dynamos, and this was quickly getting outdated. But contrary to popular belief, solar panels in Nomifactory are somehow overpowered. Since my space station was constantly facing the sun, I could theoretically generate millions of energy units per second for free simply by placing solar panels. However, between me and the solar panels were approximately a few hundred steps and new materials I had never seen before, with names such as inderium, Hypixel C276, stabilized americium, and a bunch of other cheap but inconvenient materials that I had to create into existence. So here's the plan. I was going to start processing the most expensive and time-consuming parts first, and then deal with all of the smaller, inconvenient steps while all of the expensive stuff was being processed. And the longest step was all Inderium's fault. Inderium needed osmiridium, more monodust, overly complicated industrial alloys. I was going to say blah blah blah, but we have reached the conclusion of this collection, blah blah blah. Not to mention that even smelting Inderium would be a massive waste of time, unless we used krypton gas for some reason. This krypton gas is a component of air that is collected from the end dimension, so I would first construct an entire industrial setup to pump air from the end, and process it on the space station. This would be done by using ender chests to teleport diamonds to the offshore air extraction facility, which was simply a gas collector and a power generator, and using ender tanks to teleport the ender air to the new ender air distillation space station sector, which is basically just a vacuum freezer to liquefy the air, and a distillation tower to fractionally separate the air into distinct materials, ranging from precious deuterium to the moderately precious krypton. And while I was in the mood to set up offshore facilities, I basically duplicated this entire transdimensional setup, to process nether air into even more obscure elements, which I had a bad feeling I would need eventually, which was why I did this in the first place. All products of distillation were to be inhumanly caged in these super tanks, which will be connected to the grand matter energy system to be accessed anywhere. And now that I had a bunch of different random fluids to boost industry, it was time to stop procrastinating on making Inderium, because I had the materials to create Inderium this entire time. But now, I would start with smelting 2 stacks of Inderium, which would take approximately 0.7 miles to cook. So I decided to focus on the next ingredient of solar panels, which is nuclear waste. Here is an explanation of nuclear waste. Whenever you put fuel in nuclear reactors, the fuel tends to become more and more impure in 2 ways. Atoms in the fuel are catastrophically split apart to create useless random elements, or they can absorb particles from the ensuing nuclear chaos, to become even heavier elements. This is how uranium becomes neptunium, becomes plutonium, becomes americium, becomes curium, becomes californium, all of which is in Minecraft, and all of which are needed for the solar panel for some reason. Therefore, the solution was to upgrade the nuclear reactor so that it would waste fuel even faster, so that I could take the nuclear waste pellets and centrifuge it into the extremely toxic radioactive substances. Usually most people would simply go onto this obscure website to calculate the most efficient, safe, and other boring adjectives fission reactor. But I was not looking for efficiency. I was looking for speed. In order to burn fuel faster, I would need to spam as many reactor fuel cells as humanly possible in the reactor, which would create Floridian quantities of heat, which is why only half of the reactor will be fuel cells, and the other half would be made up of the most overpowered coolant and Nomifactory coolers. All of this would occur in a grid pattern, which is why this design is known as a cryolattice, which is so infamous that it earned its own name, called a cryolattice. Anyways, I do not need to explain making the reactor parts because I have already explained it 3 times ever since the first reactor in episode 10. So after making all the new coolers and fuel cells and reactor casings, I would rebuild the reactor into a 5x5x5 processing monster, and I would feed it pellets of neptunium and uranium, for it to turn into nuclear waste, while I did other actually useful tasks. The solar panels I am going for are the tier 7 solar panels. Each tier of solar panel requires the tier below it, with each tier requiring at least approximately 5 different random objects. It was like a reverse loot box. It takes random things away from you, but luckily for us, and by us, I mean me, most of these were rather cheap and easy, meaning the only thing lost was time. But did I really have to manually create all of these panels? The answer is number, because with the power of the matter energy system, I could create crafting patterns for the system to automatically craft certain things, without me having to actually make it in real life in the first place. So I would put together all the patterns needed to go up to tier 7 solar panels, diamond lenses, photovoltaic compounds, glass, resonant shards, and so on. Most of these were obtainable using the various basic machines from the factory, or simply in crafting tables. Once the patterns were all complete, I would use the matter energy system to calculate how much of each material I was missing. The answer was Sunarium and Hastelloy C276, but I had wasted so much time clicking on this terminal that I now had all the nuclear waste I needed to make that. Sunarium was produced from alloy smelting americium and berkelium, while Hastelloy was yet another superalloy, which I am used to at this point. This, combined with the inderium that had been painstakingly smelted in the background this whole time, would be dumped into the system, allowing me to order 16 Tier 7 solar panels. This would amount to approximately 10 million energy units per second, which was magnitudes higher than what was being created by this pathetic dynamo farm. So after doing the Great Dynamo Extinction event, the new solar panel farm was connected to the Great Energy Grid, which will carry the base over for when I would order the next 16 solar panels, to double the energy output of this great space station. Once the other 16 solar panels were generated and attached to the Great Energy Grid, it was time to upgrade the energy grid itself, since these signalum cables could not transfer energy fast enough to keep up with the solar panel farm. So I would use the leftover inderium to upgrade the signalum cables, to quadruple the energy throughput, allowing the electron volts from the solar panel to be unleashed upon the other 95% of headquarters. In conclusion, I had practically infinite energy for now, giving me more freedom to do whatever I wanted in the factory. And the first thing I shall do with this newfound electrical surge is continue upgrading electrical grids and energy hatches around the base, which will allow the multiblocks to receive more energy, thus overclocking it for baffling processing speeds. This invigoration would require a new tier of energy hatches never seen or heard of, the ludicrous tier energy hatches. As with all other ludicrous tier technology, it would be made in the assembly line. So to prepare for the incoming wave of required ludicrous tier parts, I would use the energy hatches to also upgrade the assembly line, overclocking it to receive ZPM tier energy. This would also be done for the blast furnaces and vacuum freezers, allowing it to handle ZPM tier high-end recipes. Speaking of assembly lines, I would also integrate this assembly line with the matter energy system for wholly auto crafting. The assembly line wouldn't be used for one-time fancy crafts, it would be used regularly from now on, but automating it would be exasperating since all of the inputs were spread across all of these input hatches. So I would have to come up with some sort of system to handle all of this. Here was the plan. The fancy big crafting patterns that were used to automate large crafting table crafts could also be used to automate the assembly line, because if we think of the assembly line as basically one big crafting table with an output, then the game doesn't really care. So by programming all of the ludicrous tier component assembly line processes as simply crafting table recipes, I could troll the game into doing my bidding. Once the patterns were done, I could then use the same packagers and unpackagers I used for the large crafting tables to automate the assembly line. The packagers would be connected to all the input hatches, with each input hatch being treated as basically one slot of the crafting table. And when I decided to order one ludicrous tier motor to test it, nothing happened. I was about to call 911 emergency services, when I remembered that I could simply destroy everything and rebuild it in random configurations until it magically worked. And then it worked. With ludicrous tier technology being easier to create, it was time to go for another ludicrous tier technology. You see, you have been lied to by society this whole time. Quantum computing is not the peak of computing. Crystal computers were the tier above quantum, which is a Minecraft fact that was purposefully covered up by. These crystal circuits would be useful for obtaining the fusion reactor controller, which needs horrifically powerful computers. But these crystal circuits needed three things that science has not gone far enough to obtain: polybenzimidazole, the most advanced polymer, SMD components but red, and an upgraded version of the cleanroom, the sterile cleanroom, to do basic biological processes which are needed for the crystal circuits for some reason. So it was time to begin with the pertinent material, polybenzimidazole. This was far more complicated than any other plastic I have ever seen so far, needing more than 10 steps of pure chemical reactions. Luckily, the inputs of this chemical chain were all things that I had: potassium from ender pearls, sulfuric acid, naphthalene from coal tar, ammonia, copper, benzene from oil, phenol from coal, chlorine from salt water, meaning that the only hard part was setting up the factory to process everything. So I created several insane voltage tier chemical reactors and large chemical reactors, as well as miscellaneous machines to deal with the messy byproducts of polybenzimidazole. The first step was that ender pearls from the quote-unquote mob farm were crushed and electrolyzed for the potassium, which also gave infinite nitrogen, at a far faster rate than the Earth air processing facility could ever theoretically do. And in the chemical sector, a new insane voltage power grid would be invented. In this reactor, sulfuric acid and nitric acid were mixed to create the nitration mixture, while benzene is chlorinated for chlorobenzene. Chlorobenzene is nitrated for the 2-nitrochlorobenzene, which is hydrogenated in the presence of copper in this large chemical reactor for 3,3-dichlorobenzidine, which is ammoniated in the presence of zinc for 3,3-diaminobenzidine with a byproduct of hydrochloric acid. Meanwhile, naphthalene is treated with sulfuric acid in the presence of potassium for phthalic acid and hydrogen sulfide. Phthalic acid, sulfuric acid and phenol are reacted for diphenyl isophthalate with a byproduct of diluted sulfuric acid. Finally, in front of the row of large chemical reactors, diphenyl isophthalate and 3,3-diaminobenzidine are reacted for polybenzimidazole with a byproduct of phenol. So I could finally get polybenzimidazole sheets. All byproducts are electrolyzed and fed back into the chemical factory, or thrown away for being utterly useless. Once polybenzimidazole was safely secured in this chemical facility, I had unlocked obtaining the SMD components but read the unoriginally named advanced SMD components. These were basically a copy of the normal components, but with every part replaced by more expensive materials that did not belong in electronics. A total engineering disaster, but an absolute game design pleasure. The only parts I didn't have yet were high-speed steel Type E, made out of HSSG but with 33% more elements, and a lot of palladium ingots. Once that was done, it was oddly satisfying to automate turning expensive plastic, metals, and assorted satisfying sounding parts to be assembled into pixels on my screen. And so, the addiction deepens. Now that I had crafting recipes to order all advanced SMD components on demand, it was time for the final, but most intimidating step of all time, the sterile cleanroom. I would need to build a completely separate cleanroom, except the top layer was covered in sterile filter hatches. Each sterile filter was a nail in the coffin of the IGoByLotsOfNames nation gross domestic product, because each single filter needs a ludicrous steer motor and ludicrous steer emitter. These were orderable, but this time, I did not have enough raw materials for this project. So I would instead order more Tier 4 micro miners for the iridium I needed for the ludicrous steer parts. And I would also send out more Tier 2 miners for the radon that was required for the quantum parts of the ludicrous steer emitter. But then I had an idea that was completely unrelated to what I was doing. Wires were perhaps one of the most used parts ever consumed by this factory. So the current wire mill was one of the most painful bottlenecks of production. Therefore, I would take a slight detour just to replace it with the wire mill multiblock. I would then build this rather large factory in the ludicrous steer section of the machine quadrant. This factory would also contain multiple input buses, so that I could connect it multiple times to the matter energy system, due to the sheer amount of wire producing recipe patterns that I had. Once that was done, I realized that the multiversal mining missions had also been completed, giving me the resources I needed to order all of the ludicrous steer parts that I needed to create all of the sterile cleanroom filters. In reality, the filters also needed polybenzimidazole and naquadah and extremely powerful ultraviolet lights to drive bacteria to extinction within a 0.3 kPa radius. So I also dealt with that. I created approximately 24 sterile cleanroom filters, since the sterile cleanroom would be 5 by 5 on the inside, with the center being taken by the cleanroom controller itself. If I needed more space for future biological projects, I would simply increase the height of the cleanroom for higher volume according to Euclidean space laws and a volume formula from Google. Increasing the radius was a bad idea since this would mean making more sterile cleanroom filters, which would lead to my net worth plummeting into the negative duovigintillions. So now that I had the cleanroom, polybenzimidazole, and advanced SMD components. Actually I lied, because I would need even more stuff for assembling crystal circuits. The circuits we have made so far were based on CPU chips made from extremely abundant silicon, but the crystal circuits are based on crystal chips, which requires emeralds out of all the materials it could have been made of. Plus the actual assembling of the circuit would require ludicrous tier electronics manufacturing machinery. I am going insane. Here's how I would deal with it. Throughout this playthrough I have mentioned the tier 1, 2, 4 and 5 miners, but the tier 3 miner was simply not needed. Until now, the tier 3 miner was very cheap by this point, but the things it produced were the opposite of cheap. It could farm jackpotillions amounts of emeralds for free. And these weren't just any emeralds. Greg Tech has tiered gemstones for some reason, ranging from normal to perfect gemstones from the redacted game mode from the redacted server that does not exist. The perfect gems I obtained from this mission could then be sliced and chopped and diced into the normal emeralds, which shall be folded into emerald plates. The next thing I needed after emeralds was bacterial sludge. The bacterial sludge is made from this set of distilleries and breweries in the sterilized cleanroom I built just for this purpose. Biomass from the ancient ethanol creation facilities can be easily breeded into the bacterial sludge, which I shall store massive amounts of in this rather unsanitary drum. Now that I had emeralds and bacterial sludge for the crystal CPUs, it was time to create all of the insane voltage and ludicrous voltage machines I needed to actually process them. I would also need the ludicrous tier autoclave for the bacteria sludge step, but this would cause a slight detour because the ludicrous pumps I needed required silicone rubber, the only type of rubber I had not collected by now. So I had to spend approximately 15 minutes creating yet another chemical chain turning sulfur and a bunch of random chemicals from oil processing into this silicone rubber, which I then extruded and used for the ludicrous pump for the ludicrous autoclave for the crystal chip for the raw crystal CPU. The first step is that exquisite emeralds are cleansed in either molten inderium or bacterial sludge to create the raw crystal chip. Bacterial sludge is infinitely cheaper than inderium, but I used inderium anyways to assert dominance on basically nobody. This raw crystal chip can then be destroyed into pieces, and regrown into non-opal crystal chips, thus creating an infinite loop of hammering and bacterial autoclaving. And the next step will shock. Rather than using a laser engraver to create circuits like any other sane technology, these raw crystal chips were somehow etched in a blast furnace to create the raw crystal CPUs. The final new thing I needed were elite circuit boards, whereas extreme circuit boards were needed for the quantum circuits. This sandwich of extreme circuit boards and even more platinum could be sandwiched into elite circuit boards. This process was rather simple in reality, needing only a few more insane voltage machines that I put next to the crystal CPU processing municipality. With the elite circuit boards, crystal CPUs, advanced SMD components, and niobium titanium wires, I could finally assemble the crystal processors over the extremely loud background noises of chemistry. These crystal processors would now be the simplest insane voltage tier circuit, and the crystal mainframes would be the first ultimate voltage tier circuit I could create into existence. With the crystal computers, inderium, and a preposterously overpowered and free way of getting free electricity, I was now ready to proceed to the next phase of the fusion reactor obtaining plan, which was to actually obtain the fusion reactor. What you shall see in the next episode is something that nobody on YouTube has ever seen yet.